Hello dear students, so from today we are going to start the first chapter of class 11th chemistry, and the name of the chapter is some basic concepts of chemistry. Okay, so the first topic that we would study here is the scientific notations. So what are the scientific notations that we would study first? So scientific notations are the exponential notation that can be written in the form of n multiplied 10 raised to the power n. What does it mean? So let me write this. Scientific notations are the exponential notations that can be written in the form of n multiplied 10 raised to the power n. Okay, because exponential form means something you are writing in exponential form, something you are writing in the form of the powers, like 7 multiplied 10 raised to the power 6 4. These are the exponential form, because you have written something in the terms of the power, like 6 raised to the power 5. This is in exponential form. Okay, so something you are writing in exponential form, but you are writing this in terms of n multiplied 10 raised to the power n, where this small n is what? Where this small n is an integer. This could be positive integer as well as the negative integer is an integer. Okay, and this capital N is this capital N. This would vary from capital N would vary from this capital N, and this capital N would vary from 1.000 to 9.999. Means this capital N should not be less than 0 and should not be more than this 9.999. This, okay, it should not be 10 point or 11 point something, or this n cannot be 0.5 or etc. Okay, so this n would take the value from between 1.000 to 9.999. Okay, it would take the value like 2 point something, 3 point something, 4 point something, 5 point something. So it would take these values there. Are you getting this? So the n would take the value between 1.000 to 9.9999. This one. Are you getting this? Yes. So let's write in exponential form some decimal expressions. I am giving you some exponential notations I am giving you here, that you would write in scientific notation. Okay. So let me write. Let's say suppose you have to write some examples we would study first. Let's say you have to write 0.0006 in scientific notation. So how would you write 0.0006 in scientific notation? How do you write this in scientific notation? Now if you are to write this in scientific notation, you would have to shift the decimal from towards the right. You would shift this decimal towards the right, then it would be 6 point something, or not? Yes or not? Yes, because this n would take the value here as 6 point something. Okay, because n would vary from 1.00 to 9.999 this way. Okay, so this n should take the value here 6 point something. So this decimal is to be shifted towards the right. If it is shifting towards the right, remember this, if you are shifting the decimal towards the right, then you are subtracting the power. That you have to understand. Means rs. What does it mean? If you are shifting the decimal towards the right, then the power would be subtracted then. Okay, so how would you write this? I would write this in the form of like 6.0, because I have shifted the decimal here. Okay, now how many places? 1 2 3 4. I have shifted it 4 places here. So I would write this in the form, because the power is to be subtracted, so I would write this as 10 raised to the power minus 4. So 0.006 can be written as 6.0 multiplied 10 to the power minus 4. So this is the scientific notation. So you can match it here also. N is 6.0, because n is taking the value from varying from 1.00 to 9.99 something. So in between this 6.0 is in between this. Yes, and 10 is the minus 4. This n is this small as n is minus 4, because n could be an integer, whether it can be positive also or negative also. Okay, if you are to shift the decimal towards the right, then you are to subtract the power. That you have to remember. Okay, let me give you another example. Let's say I have written at 0.006 multiplied 10 to the power minus 6. So how to write this? I have written in exponential form, but this is not this not has been written in the scientific notation. Why? Because the value of n is not between 1 point this is and 9 point this is. It is not between this. Yes or not? So how do you write this in scientific notation? So to write this in scientific notation, the decimal which is here is to be shifted towards the right again. Again we are shifting the decimal towards the right. If you are shifting the decimal towards the right, then power is going to be subtracted. So how do you write this? This can be written as 6.0 multiply 10 to the power minus 6 is already there. So how many power you would subtract there? 1 2 3, because you are moving these 3 places here. You are shifting these 3 places here. So you would subtract here 3 minus 3. So this would be 6.0 multiplied 10 raised to the power minus 9. So this is the scientific notation here. So this is how you would write in scientific notation. Okay. Now here I am shifting the decimal towards the right. Let's say you have to shift the decimal towards the left. So how do you shift the decimal towards the left? That you would talk now. Okay. If you have written this, let me talk something more here. Okay, now you have to shift the decimal towards the left. Okay, let's say some exponential form 623 point let's say it is 04 multiplied 10 to the power, let's say it is 23. Now you are to write this in scientific notation. This is not in scientific notation because the value is n here should be between 1.00 to 9.99, but it is more than 9. You could see it here also. Yes or not? So to write this in scientific notation, you are to shift the decimal towards the left now. You would shift it towards the left. So you would write this as 6.23. This decimal you would shift here. So I can write this 6.23. Other also you can write, but only this much I am writing here. Multiply 10 raised to the power 23. Now remember, if you are shifting the decimal towards the left, then you are to add the power there. What would you do? You would add the power. So how many places you are shifting? 1 2. So you would add here 2. So this would be 6.23 multiplied 10 to the power 25. Okay, I have not in the other digits as 04 also you can write as 6.2304, which is left there, that also you can write, but I am leaving here. This is okay. Are you getting this? Yes. So this is how you would write the scientific notation. Okay, let me give you some more here. Okay, let's say suppose it is 623. Let me erase this first. Let's say it is 623.04. 623.04 multiplied, let's say it is 10 to the power minus 3. So how to write this in scientific notation? So again, to write this in scientific notation, you are to shift the decimal towards the left again. If you are shifting it towards the left, so remember the formula LA. So while you are shifting towards the left, you are going to add there then. In case in case you are shifting towards the right, then RS means you are to subtract the power. In case you are shifting towards the left, then LA means you have to add the power. Okay. So how many places you are shifting here? You would shift it here. So 2 places you are shifting. So you would add there 2. So I would write it as 6.23 multiplied 10 to the power minus 3 plus 2. So it can be written as 6.23 multiplied 10 to the power minus 1. So this is how you would shift the decimal. Are you getting this? So this is how you would write in scientific notation. Just note it down. Then after we will be discussing about the significant figures. Now the next thing that we are going to study here is the significant figures. So what are the significant figures? Significant figures are the meaningful digits with certainty plus uncertain digits. Okay, means certain digits and uncertain digits. We count these as the significant figures. Okay, means significant figures are, so let's write it here. Significant figures are the meaningful digits. Significant figures are the meaningful digits with certainty. With certainty means all the digits which are meaningful there with certainty would be termed as the significant figure, plus the uncertain one, plus which is estimated or uncertain, plus which is uncertain. So this would be the significant figure. So how do you write the significant figures? See, there are some rules. With the help of the rules, you will know about the significant figures, because with the help of the definition, it would be impossible for you to know what are the significant figures. So let me tell you the rules there. So with the help of the rules, you will get to know what are the significant figures. Are you getting this? See, there are some rules. So write down if you have written this. Sorry. if you have written this, write down the rules for the significant figures. Okay, write down there rules for significant figures. Let me erase this. Rules for significant figures, or you can write rules to determine significant figure, that is SF. So how do you determine significant figures there? Okay, so first rule is right there, all non-zero digits in a number are significant. Okay, all first rule is all non-zero digits in a number are significant figures. All non-zero digits. Let's say I'm writing 3.24. So how many non-zero digits are here? 1, 2, 3. So so significant figures, how many significant figures here? So here significant figures are 3 here. Okay, because 3 non-zero digits are there. So this is the first rule. Means all non-zero digits would be counted as the significant figures. Okay, and let's move to the second rule. All zeros between two non-zeros would also be counted as the significant figures. Okay, so right there, all zeros between two non-zeros are also counted as significant figures. So what is this? Let's say I'm writing here like 3.004. So can you tell me the significant figures here? Look here, there are two zeros between two non-zeros. So all the zeros between two non-zeros, what is the rule? All the zeros between two non-zeros would also be counted as the significant figure. So how many significant figures here? SF, how many here? If you count 1, 2, 3, 4. So total 4 significant figures would be here. So this is the rule number 2. So this is how you would count or you would calculate the significant figures. Hope you are getting this. Now let's move towards the third rule. Third rule says that all zeros before the non-zeros are non-significant. That you have to remember. Okay, all zeros before the non-zeros are non-significant. What does this mean? Let me write a number here. Let's say it is 0.0042. Now if you are to write the significant figure, how many significant figures are here? Now if you see, rule is all zeros before non-zeros. 4 and 2, these two are non-zero, and before this all zeros are there. So all zeros before the non-zeros would be what? Would be non-significant. So these three would be non-significant. So how many significant figures here then? Only 2. So it implies SF would be 2. So here we have 2 significant figures. Only 2 significant figures are here. Are you getting this? Yes. So this was rule number 3. Now let's move towards the rule number 4. And the rule number 4 says that, let me write it here. Rule number 4 says that all zeros after the non-zeros would also be counted as the significant figure. Are you getting this? This is the rule number 4. All zeros after the non-zeros would also be counted as significant figures. Okay, let's say I'm writing a digit here. Let's say it is 2.2000. Okay, now can you tell me how many significant figures are here? Not only 2, because all zeros after the non-zero, like 2 is non-zero, this 2 is also non-zero. So after non-zero, all zeros would also be counted as the significant figure. So here, how many significant figures here? 1, 2, 3, 4, 5, 6. So total SF means significant figures are here. 6 significant figures are here. Okay, let me give you some more. Like if you are to find out, like, so for example 0.1230, so can you tell me how many significant figures are here? Remember this, all zeros after the non-zeros would be counted as significant figures, and all zeros before the non-zeros would not be counted as a significant figure. Remember this. So this one zero you would not be counting as the significant figure, but this one zero would be counted as the significant figure. Are you getting this? We have already the rule there. Okay, the rule number 3 or 2, whatever is there. So it says that all zeros before the non-zero, all zeros before the non-zeros would not be counted as the significant figure, but the zeros after the non-zero, these are non-zero, 3 is non-zero, so the zeros after the non-zero would be counted as significant figure. So how many significant figures are? 1 2, this would, you would count this, but this one you would not count. So 1 2 3 4. So how many significant figures are here? There are 4 significant figures. Okay, now I'm asking one more, 0.0123. Now can you tell me how many significant figures are here? Just now, rule number 3, it says that all zeros before the non-zeros would not be counted as the significant figures. So here is the case, all zeros, one is non-zero, so before non-zero all the zeros would not be counted as the significant figures, so you would leave these two. So how many significant figures are? Only 3 significant figures are here. Okay, so answer would be 3 here. Are you getting this all? Yes. So this was your rule number 4. Now let's move towards the rule number 5. And it says that if I am writing or indicating or mentioning the commodities after the given digit, if I am mentioning the commodities, let's say I am writing 10 pencil. I have mentioned the commodity also here. Let's say I am writing 10 books. Okay. So if you are mentioning the commodities after the given digit, then the number of significant figure would be infinite. There would be infinite number of significant figures then. Okay, if you are mentioning the commodity, this is the rule. So the rule says that if the commodities has been mentioned after the digits, then the number of significant figures become infinity. Are you getting this? Yes. So this is I am writing 6x. 6x. So how many significant figures here? You would write as, there are infinite number of significant figures would be there. Are you getting? So this was your rule number 4, 5, oh yeah, 6 1. Okay. So 6 1 rule is that, write it, all commodities mentioned after the digit, sorry, just let me write it here. If commodities are mentioned, then there are infinite number of SFs, significant figures. Okay, this is the next rule. Okay, let's say 6x. So how many significant figures are there? Infinite. Okay, now the next rule, in exponential, if something has been given in the exponential form, then you are not to count the power. The power would not be included as the significant figure in exponential form. In exponential form, the powers would not be counted as significant. Let's say, suppose I am writing here 6.023 multiplied 10 to the power minus 5. So can you tell me the significant number of significant figures here? You would not count the powers. Okay, if something has been given in the form of the exponential, this has been given in exponential form, 10 raised to the power, so you would not count this complete. So only this much you would count. So how many significant figures are here? Because 0 is between two non-zero, so this 0 you would count. Okay, do not think that we are not counting this 0. You would count this 0. Why? Because this 0 is between two non-zero. If the 0 is between two non-zero, then you would count this. So how many significant figures are here? 1 2 3 4. So there would be 4 significant figures. Okay, let's say suppose I am writing 200. Sorry. Okay, let me write here. Can you tell me the number of significant figures here? Yes, tell me. Yes, all the zeros after the non-zero, 5 is non-zero, and after non-zero all the zeros would also be counted as the significant. So number of significant figure would be how much here? 1 2 3 4 5, 5 significant figure. Now suppose if I write it like, I can write it like this also. 250 multiplied 10 to the power 2. 2 0 here, 1 0 here. So this can be written in this form also. Now can you tell me the significant figures here? Now you would not be counting this one because I have written this in exponential form. Now you would not count this as the significant figure. Only these three would be the significant figures. So how many significant figures now here? 3. Now I have varied the significant figures. Now let me write this 0 again here. So I can write this again as 25 multiplied 10 raised to the power 3. It can be written because 1 2 3, so 3 digits are there. So I have written 10 raised to the power 3. So now again you would not be counting this as the exponential form. So how many significant figures here? 1 2. So significant figures now here only 2 significant figures. So this is how you would write the significant figures of the given decimal expression or the exponential one. Okay, so that's all for today. Would be discussing some more topics in the lecture set. Till then, stay tuned and keep watching. Thank you. Have a good day.